Good morning students. This lecture is in continuation with the previous lecture. Today's topic we'll discuss is aerosols, inhalers. Now aerosol. An aerosol is a suspension of fine solid particles or liquid droplets in air or another gas. Aerosols can be natural, anthropogenic. Example of aerosols are naturally like fog, dust, forest exudates. Now I'll explain you the aerosols. As a liquefaction of a gas can be achieved by applying pressure on it and keeping the temperature below the critical temperature. But when the pressure is reduced, the molecules expand and the liquid converts back into the gaseous state. And aerosols are based on the principle of reversible change of state on the application and release of pressure. As in pharmaceutical aerosols, a drug is dissolved or suspended in a propellant. Propellant, a material which exists as a liquid under the pressure conditions prevalent inside the container but gets converted to gas under normal atmospheric conditions. The container designed in such a manner that on depressing a valve, some of the drug propellant mixture is expelled out due to excess pressure inside the container. The aerosols container are filled either by cooling the propellant and drug at a low temperature within the container, which is then sealed with the valve. Alternatively, the drug is sealed in a container at room temperature and the required quantity of propellant is forced into the container under pressure. These are pressurized dosage forms. In both the cases, when the container is at room temperature, the part of propellant is in the gaseous state and exert pressure necessary to exudate the drug, while the remaining is in the liquid state and provides a solution or suspension vehicle for the drug. I have explained you the method of aerosol preparations, how aerosols are filled. Now this picture you can see the aerosol dosage form. These are aerosol dosage forms. Next topic is relative humidity. What is relative humidity? It may be defined as the ratio of amount of water vapor in the air at a specific temperature to the maximum amount that the air could hold at that temperature. It is expressed as percentage. In other words, we can say that the relative humidity is a ratio between the actual water vapor pressure to the saturation water vapor pressure at a prevailing temperature. You can see the formula of relative humidity: actual water vapor pressure upon saturated water vapor pressure into 100, and it is expressed in percentage. The amount of water vapor the air can hold increases with the temperature, means relative humidity decreases with increasing temperature if the actual amount of water vapor stays the same. Next topic is liquid complexes. Liquid complexes. Complex fluids are binary mixtures that have a coexistence between two phases. Means binary means two phases: solid liquid, solid gas, liquid gas. They exhibit unusual mechanical responses to the applied stress or strain due to geometrical constraint that the phase coexistent imposes. The mechanical responses includes transitions between solid-like and fluid-like behavior, as well as fluctuations. Their mechanical properties can be attributed to characteristics such as higher disorder, caging, clustering on multiple length scales. Example is shaving cream. Example of complex fluid is shaving cream. Without stress, the foam applies to be a solid. It does not flow and can support light loads. However, when the stress is applied, the shaving cream flows easily like a fluid. On the level of individual bubbles, the flow is due to rearrangement of small collection of bubbles. On this scale, the flow is not smooth, but instead it consists of fluctuation due to rearrangement of buffer and releases of stress. Next topic is liquid crystal. It's the fourth state of matter that is called liquid crystal or mesophase. It is a state that occurs between solid and a liquid. Liquid crystals में क्या होता है कि they possesses the characteristics of both liquids and crystalline solids. That's why its name indicate liquid crystal. It indicates that it possesses the properties of both liquids and crystalline solids. In crystalline solid state, the molecules are held in position by intermolecular force. The particles in a solid move but cannot cross each other because the attraction of neighboring atoms or molecules are too strong. As I have already told you that in solid the intermolecular forces of attraction are strong. The molecules cannot move. In the liquid state, the molecules move to random positions. But in the liquid crystalline state, the increased molecular motion overcome the weaker forces, but the molecules remain bound by stronger forces. This produces a molecular arrangement where the molecules is layered, but within each layer, the molecules are arranged in a random position. The molecules can slide one around the other, and layers can slide over one another. This molecular mobility generates fluidity in crystalline liquid state. You can see in this picture, first picture shows crystalline solid phase, second picture shows liquid amorphous phase, and third picture you can see liquid crystal phase. Now types of liquid crystal. There are two types. First one is thermotropic liquid crystal. Liquid crystals are said to be thermotropic if liquid crystalline properties depend upon the temperature. First one is pneumatic liquid crystal, second is smectic liquid crystal, third is cholesteric liquid crystal. Now we will discuss about pneumatic liquid crystals. Here the molecules have no positional order, but they have long range orientational order. Okay, smectic liquid crystal. In this, the molecules have both positional order and orientational order. Okay, both orders are there, positional as well as orientational order. Third is cholesteric liquid crystal. It may be defined as a specific type of pneumatic liquid crystal in which thin layer of the parallel molecules have their longitudinal axis rotated in adjacent layers at certain angle. Okay, you can see in this picture. Second is lyotropic liquid crystals. Liquid crystals are said to be lyotropic when they are prepared by mixing two or more substances of which one is polar molecule, are known as lyotropic liquid crystals. Okay, means they are made by mixing two substances in which one is a polar molecule. Now that's all for today. Thank you.